Good morning. The topic for today is parallel circuits. So today we are going to discuss about parallel circuits and how the connections are made. A parallel circuit is way of connecting components on separate branches so the current can take different routes around the circuit. Electrical circuits can be connected in parallel or in series. A series circuit has all the components in one loop connected by wire, so there is only one route for the current to flow. So in series, the components are connected one after the other. It is called cascade, or it is called as a one-to-one connection. So the same current flows, but the voltage dropped across each element will vary. Whereas in a parallel circuit, the components are connected across the same 2 points. Hence, voltage dropped will be the same across all the elements, and the current flow will be split as I1, I2 across each resistor. So in parallel circuit, uh, V total is equal to V1 equal to V2 equal to V3. So voltage is same across all the branches. Each component gets a full supply voltage, whereas the current across each will be different. So now if the total current is I, then I will be split as I1 along R1, I2 along R2, I3 along R3. So current splits among branches depending on resistance. Low resistance branch, more current. So current always takes the least resistance path. So if there is a short circuit, then entire current will flow through it and no current will pass through the other branches. So resistance, now the total resistance or the equivalent resistance is going to be 1 by R equivalent or R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So the total resistance in parallel is less than the smallest resistor. More branches, less total resistance. So now we'll look into the problems. So given R1 is equal to 6 ohms, R2 is equal to 3 ohms. So 1 by R equivalent or R total is 1 by R1 plus 1 by R2. Hence 1 by R total is equal to 1 by 6 plus 1 by 3. So 1 by R is equal to 3 by 6. So R total or R equivalent is 2 ohms. The next problem, V is given as 12 volts, R1 is 6 ohms, R2 3 ohms. So find R total or R equivalent. Uh, so R equivalent is going to be 1 by 6 plus 1 by 3. So that we have found out to be 2 ohms in the previous problem. Now the total current is going to be the voltage drop by R equivalent. So 12 by 2, that is 6 amps. Let us look at the third problem, current across each resistor. So I1 is going to be V by R1, so 12 by 6, 2 amps. I2 is going to be V by R2, that is 12 by 3, that is 4 amps. I total is equal to 2 plus 4, that is 6 amps. Now problem 4, given 3 resistors, R1 is 4 ohms, R2 is 4 ohms and R3 is 4 ohms. Now R 1 by R equivalent is 1 by 4 plus 1 by 4 plus 1 by 4, that is 3 by 4. So R total is equal to 4 by 3, 1.33 ohms. Now continue with the problem 4. If the supply voltage is 12 volts, then I total is 12 by 1.33, that is 9 amps. Now current in each branch is going to be 12 by 4, that is 3 amp. That is here, since all the resistance are same, so we can divide the total voltage divided by 4 ohms. So you will get 3 amps. Now what happens if one branch fails? Okay, so isolated failure, only the failed component is affected. Component failure, a part of the system breaks down. Alternative path, the system uses other routes for function. Continued operation, systems keeps working despite the failure. So this is the main difference between the series connection and parallel connection. In series connection, if a component fails, then the system it opens, the circuit opens, and there is no path for the flow of current. Whereas here, if one component fails, the still the circuit works because the current can go through other branches. So parallel circuit advantage, failure tolerance, current divides, multiple path, decreased resistance, same voltage. So same voltage is applied across all the resistors. There is decreased resistance, reduces overall resistance, increasing efficiency. Multiple path provides alternative routes for current flow. Current divide distributes current among parallel branches. How to ensure continuous lighting in a circuit? Parallel circuit ensures continuous lighting. Series fails completely when one bulb fuses. So we come to the end of this section. Thank you.